Alright, welcome back to my channel once again. It's Muhammad. In this video we are going to look at the real number system, and we will see which of the sets in the real number system we can represent as what interval. We can represent as an interval notation. So let's quickly look at the natural numbers, natural or counting numbers. Let's look at what it is. So I'm not going to define them. I'm going to just list the sets. It's just the counting numbers 1, 2, 3, 4. If you check up to infinity. So if you observe this set, we cannot just represent it as this 1 to infinity. If we represent this as this, there's a problem, because this one we know natural numbers. If I have x as my natural number, then my next natural number should be x plus 1. And here that rule is not applicable here, because if I say 1 to infinity this way and I represent it this way, 1 comma infinity this, then with an open interval, it means 1 is not even part of the distance. 1 is not even part of the distance. 1 is not part of the set. So this set, maybe this is set A. This set is not the same as the set of natural numbers, because the set of natural numbers are counting numbers 1, 2, 3 up to infinity. Is that fine? So let's not confuse the natural numbers with this guy, set A, the open interval 1 to infinity. This one starts from 1, 2, 3, 4. They are countable. But this one, this set A, is uncountable. Is that fine? Let's look at the next group of the next set of real number. So after natural numbers, let me cancel everything, then have my next set 2 whole numbers. So whole numbers 2, we can't represent it as 0 to infinity. No, we can't have something like this as whole numbers. So 1, it starts from 0, right? 0, 1, 2, 3 up to infinity. So this is how we can represent it. So it's just a set with a difference. I have my first whole number as x, then the next one will be x plus 1, x plus 2, x plus 3, and consecutive numbers up to infinity. But this one doesn't follow that rule. It does not follow that rule. Follow the consecutive rule of whole numbers. So it doesn't follow the consecutive rule, which is x plus 1. Sorry, x plus 1, not x plus 0. Is that fine? So this one is not also qualified. If this is my set A, this set is not qualified to be what? A whole, to be a set of whole numbers. In fact, the set of whole numbers can be found here. So if the set of whole numbers is represented as W, so W, let me change them. So W as our whole numbers, and A is this set we have here. Then W, mathematically, W is a subset of what? E. Because everything in what? W can be found in A. Because as we continue listening, even though we can't list all the numbers between 0 and 1, we will definitely move to what? 1 and 2, 2 and 3, 3 and 4, up to what? Infinity. So this set contains W, which is the set of whole numbers. Is that fine? Okay, so I hope this is clear. Let's move on to the next set. I want us to reach the real numbers itself. So let me clean my space here. Okay, so the next one, 3, is the set of integers. Integers contains negatives in addition to whole numbers. So just whole numbers but with their negatives. So maybe from negative infinity, negative 3, negative 2, like 1, 0, 1, 2, 3, up to infinity. And this is not also the set negative infinity, so it's different from the set negative infinity to what? Positive infinity. This and that are two different. So this, let's say this set A, let me take this away. So if these are integers, okay, let me use the universal denotation for what? Integers. Okay, we have something like this. It's not the best, but it's just trying to depict the set of integers that we know. Something like that. Okay, let me see. Okay. Okay, something like that. I'm not from the drawing. I can't write it well, but something like that. That's fine. So something like the Z for integers. So in this one, let's say A, we'll come to know what it is very soon. It's different from set of integers. Set of integers differ the difference is 1. It has a common difference of 1. So if my first set is x, the next one will be x plus 1, the next one will be x plus 2. So I can use this system to generate all what? Integers. In fact, set of integers are countable. We can count the numbers. So they are countable. Whilst negative infinity to infinity isn't what? Negative infinity to infinity isn't a countable set. It's infinite set. It's infinite. You will say this one is around to infinity. Well, we don't know the end, but we can. If you tell me maybe this one will end at 1,000, okay, so I can count. I have the patience to do the counting. But this one, even numbers between 0 and 1 alone, we cannot afford to count all the numbers between these two numbers. So this one is infinite. We have infinite number of elements in this very set. So don't mistake the set of integers for what? A set that is from negative infinity to infinity. It isn't the same. Is that fine? Okay, let's look at the next set. I believe this is okay for you. So let's look at the next one. So 4. So the fourth one, we can see we have the set of rational numbers. Rational usually so represented as Q. It's usually represented as Q. Okay, so let's look at it. Rational numbers, it contains fractions, and the kind of fractions it contains this kind of fractions, maybe 2/3. We have all fractions are rational numbers. Then decimals to 0.2, maybe terminating decimals and recurring. Both terminating and recurring decimals are what? Rational. 0.2, 0.23. So any number that can be expressed in the form P/Q, in fact, any number that can be expressed in this form is what? A rational number. So that means that our integers, set of integers, is what? A subset of what? Of the set of rational numbers. Is that okay? So because it contains fractions and decimals in addition to what? In addition to the integers that we have. So it can also be negative or positive, it doesn't matter. That is rational numbers. But still we cannot say that it's the same as this, negative infinity to infinity. It isn't the same, because from negative to infinity to infinity we might have root 2, we might have pi, because as we continue to list the numbers we might have these numbers, and these numbers defy the definition of rational numbers, because we cannot express this as p over q, we can't express this as pi, which is 2.1334 up to infinity. We cannot express it as let me check the value of pi very well. It's 342 running to infinity. We cannot express this as what? A fraction, so it's not qualified. But we can write this set. We cannot write this as an interval. We must, if we are going to write it, then we must define the interval, because we cannot express everything in this interval 0, 1 as a fraction, because there are a lot of numbers there and we cannot express everything. From 1 to 2 we cannot express it as what? A fraction. From 2 to 3 we can't express it as a fraction. Here, if you are studying mathematics, you or any mathematical related subject or course, you will come across this guy, the E, and you know what number it represents, and it might be in this what? In this interval, which is not what? A rational number. Is that okay? Okay. So rational numbers are not also qualified to be written as what? Intervals. If you are going to write it as an interval, then you must define your interval. Okay, so that is it. Let's look at the next one. So 5, we are going to look at irrational numbers. Irrational. So that's just the opposite of rational numbers. So I've listed some: root 2, pi, e, root 3, 2.27458 3, 2, 1, 1, 0, 0, 8. You see, up to infinity. It's not recurring and terminating. So all these are irrational numbers. Is that okay? And all that we have listed, from natural numbers to irrational numbers, can be classified as the CIF one we are coming to look at, which is what? Real numbers. Now we have all the numbers combined. So it can be 0, 1, 2, it can be rational, irrational, everything can be. So if you don't want to stress yourself, you can just use the interval negative infinity to infinity. So this will capture all the numbers we have done. So it will capture everything, so all the numbers combined, natural numbers, whole numbers, integers, rational numbers, irrational numbers, all of them combined will give us what the real number system, which is what from negative infinity to infinity. Is that fine? So we have this what as we have this one as the set of what real numbers. So if you see negative infinity to infinity, it's just representing what real numbers. So that's just a real number system. Okay, so if we are representing this in a graph, in a number line, you might be wondering how it will be. Okay, so we have our 0 at the center from negative infinity to infinity. We don't, so if I have this interval 0 to infinity, it's just 0, then I have my line there, because moving to infinity, you can't tell where it will stop. So the same thing, this number line itself is just the set of real numbers from negative infinity to infinity. Is that fine? So you cannot come and open your circle somewhere or close your circle somewhere. No. So if this is how I represent it. So 0, if 0 is not included, so because it is opened at 0, it means my start from 0 is not part, excluding 0 to infinity. All positive numbers is excluding 0. So we have an open circle at 0, moving to positive infinity. The same way if it was the other way around, maybe from negative infinity to 0, then we will have our this thing open to the left. So moving to what negative, so it's moving to what negative infinity, excluding 0. But if we were having a closed interval at 0, that means we will have to tick this circle, have a tick circle at 0. Is that fine? So if you are asking me, okay, let me give you the question, even though I've just stated the answer, but you might not get my answer clearly. So I would like you to represent this one. Represent the set of real numbers in a number line and drop it in the comment section for me. I hope my video is helpful, and I hope it will help you in understanding the interval notation very well. Maybe I will record another video. I'm thinking of recording about these sets, maybe union or intersection or subsets. Maybe your involvement or your recommendations might help me do more on this very topic. If you find it helpful, I'm grateful. Give me a like and share with others to also enjoy and benefit from this. Thank you very much for your time and attention. Have a blissful time.